Hello everyone and welcome to this session. My name is Rajiv Chakrabarty. I am the Principal Developer Advocate for Amazon MSK. Today, we are going to be talking about real-time data streaming architectures and the speed real-time data stream processing can provide in gaining insights on data and taking actions on it. Let's take a look at what we have on the agenda today. We will begin by talking a bit about what real-time analytics is and how data streaming can help you draw key insights in real time from your data. We will talk about the various stages of building a data streaming pipeline and what tools and services you have at your disposal at these different stages. In the end, we will highlight a few real-world use cases of real-time analytics in play. So let's dive in. First, the sheer volume of data being produced in the world today is reaching astronomical proportions. Just as the universe is expanding at a faster rate, data is being produced at a faster rate. The number of smart devices that generate data from our homes, our cars, and even our bodies has grown manifold in the past few years and is projected to grow even faster in the next 10 years. Approximately 90% of the world's entire data was generated in the last 2 years. As of 2018, there were 2.5 quintillion bytes of data produced each day. You can only imagine how much is being produced today. Not only is data being produced at high volumes, it is being produced continuously and is coming at us at lightning speeds due to an explosive growth of real-time data sources. Machine data already makes up a large percentage of our digital universe. Whether it is log data coming from mobile and web applications, purchase data from e-commerce sites, or sensor data from IoT devices, it all delivers information that can help companies learn about what their customers, organizations, and businesses are doing right now. Then there is a variety of data sources that are producing this data. All these data sources produce data in their own format at different velocities and sizes, and have different sensitivity to the information that data contains. Therefore, the need to process this data is also varied in nature. So how much is this data worth? Well, it depends. This is a chart that was published by Forrester and is called Perishable Insights. And it basically says that there is a shelf life for data. So recent data is highly valuable if you can act on it in time. Processing real-time data as it arrives can let you make decisions much faster and get the most value from your data. As an example, take a fraud prevention system as opposed to a fraud detection system. If your credit card is stolen as someone goes through the checkout counter at a store, you would want the swipe information to be processed in seconds and generate alerts and decline the transaction. If that does not happen, then you can only depend on a daily or monthly process where it is flagged and you get informed days later, or you can contest a transaction. Obviously, there is value in detecting the fraudulent activity in real time and preventing the transaction from going through. However, building your own custom applications to process streaming data is complicated and resource intensive. You need to train or hire developers with the right skill sets, and then wait for months for the applications to be built and fine-tuned, and then operate and scale the application as the business grows. All this takes a lot of time and money. And at the end of the day, lots of companies just never get there. They settle for the status quo and live with information that is hours or days old. So since insights from data are perishable and can lose value quickly, stream processing allows analytical insights to be gathered and acted upon instantly. Batch processing data doesn't allow for real-time risk mitigation or customer authentication. The customer experience can therefore be ruined and is hard to recover from if action isn't taken in real time. Acting on real-time data can help prevent fraud and increase customer loyalty. Untimely data, on the other hand, can inhibit your firm's ability to grow. So what does that tell us? It tells us that deriving real-time insights is important. Let's go through some of the common real-time analytics use cases. First, anomaly and fraud detection in real time. Organizations must be able to identify security breaches, network outages, or machine failures in real time. I talked about a fraud prevention use case for a credit card company. Next, tailoring customer experience in real time. Businesses continuously push features on their websites to respond to ever-changing competition, drive higher sales, and enhance customer satisfaction. With the help of real-time streaming and analytics, businesses can understand a given feature's ability to drive more traffic in real time for a better adoption. Next, we look at empowering IoT and analytics. Industrial and commercial IoT sectors, such as manufacturing, oil and gas, transportation, smart cities, smart buildings, and others, have use cases ranging from predicting the failure conditions in a manufacturing process based on live sensor data, to improve yields, to detecting anomalies in an oil rig. These use cases can utilize real-time stream processing. Next, we look at predictive maintenance, which goes hand in hand with IoT. In manufacturing and supply chain, the low-hanging fruit is predictive maintenance. For example, optimization of supply chains for spare parts and raw materials, predictive capacity planning, process improvement, and quality management. Next comes nourishing marketing campaigns. For improved advertising and marketing campaigns, Stream Analytics can combine data from multiple sources, such as ad inventory, web traffic, click logs, customer demographic, and behavioral data to uncover insights that improve audience targeting, pricing strategies, and conversion rates. Next is real-time personalization. Retail businesses can use real-time Stream Analytics to help improve search relevance with a dynamically changing product catalog in terms of price and availability, as well as user preferences based on current and past behavior. And finally, supporting healthcare and emergency services. In clinical healthcare, real-time analytics provides the ability to monitor patient safety, personalize patient results, and assess clinical risk, as well as reduce patient readmissions. This is a visual representation of the different timescales that are suitable for various analytics use cases. On the left, you have use cases such as messaging between microservices and web and mobile notifications that require milliseconds latencies. These are near real-time use cases. In the middle, there are use cases such as log ingestion and CDC, which can afford a few seconds worth of latency. And on the right, you have use cases such as streaming ETL, writing data into data lakes and warehouses for use at a later time. These can be processed and analyzed a few minutes after data is available. However, all these still require continuous processing as data is produced constantly. However, data streaming is challenging to set up and get right. When you self-manage and run a streaming platform, you need to provision servers, configure servers manually, and make sure configuration changes are replicated across all nodes in a distributed cluster. Replace servers when they fail, perform server patching and upgrades, make sure the cluster is architected for high availability, make sure data is durably stored and encrypted, and provide security, authentication, and authorization to cluster resources. You also need to set up monitoring and alarms and carefully plan scaling events so as to support load changes, which in itself is a tricky process. All of this requires a lot of expertise and time and money to operate and maintain. That's where AWS can help. We provide a suite of services across the streaming ecosystem that takes the undifferentiated heavy lifting off of your development teams and lets them focus on creating value for your customers. AWS streaming services are easy to use. We provide a console and a command line experience to help you get started quickly, and also provide administrative and read-write APIs and SDKs to communicate with our services using your desired set of development tools. We also provide support to help your teams automate their deployments. Our services are also elastic, and we offer elasticity in all our streaming services, so your infrastructure responds to your needs. We also bake in high availability in our services by default. This gives customers the comfort of knowing that their data is available when they need it, irrespective of infrastructure outages. We also strive to provide native integrations with other AWS services so you don't have to maintain those bindings yourself. And our services are fully managed. We invest resources in operating your infrastructure and try to detect and fix things when things go wrong. And finally, you pay for what you use. Okay, so in order to understand the basics of real-time analytics and data streaming capabilities, there are 5 core stages to understand. First, the source of data. Essentially, where is this data coming from? Is it mobile? Is it web clickstream? Log analytics? Is it coming from IoT devices, smart devices, etc., etc.? Data that needs to be ingested into the stream. This requires the ability to scale a solution that can capture data coming from hundreds of thousands of devices in a reliable manner into one stream for analysis. Data is then stored in the order it was received for a set duration of time and can be replayed indefinitely during this time. As the data is stored in the stream, it can then be processed by real-time applications to generate real-time analytics, execute real-time ETL, and then deliver the continuous data to an end destination such as a data lake, like Amazon S3, a data warehouse like Amazon Redshift, or other database systems such as Amazon DynamoDB. Essentially, you enable ingestion and capturing of the real-time streaming data, store it based on your processing requirements, and process it to tap into real-time insights. You can then send alerts, emails, notifications, or trigger other event-driven applications, and finally move the data to a persistent layer. As I stated earlier, in today's world, we have many and varied sources of data that often produce data continuously and in large volumes. In addition to the sources of data, you need mechanisms to send the data from those sources to the stream storage platform. The AWS streaming services have native AWS toolkits, libraries and agents, and native integrations with other AWS services that enable direct sending data, and connections for open source, connectors for open source, and third-party tools that integrate with it. For a stream storage platform, there are a few requirements. It should provide the ability to write in high volume, very efficiently and reliably. It should store data securely and cost efficiently. Consumers should be able to read from it in real time. One-to-many stream processing applications should be able to consume from it at the same time. And consumers should be able to rewind and read data from a different point in the stream at will. AWS offers 2 services in this category. Amazon Kinesis Data Stream, which is a cloud-native solution that is ideal for applications built in the cloud and for the cloud. And Amazon Managed Streaming for Apache Kafka, which is a managed service for popular open source streaming software, Apache Kafka. With Kinesis Data Streams, administration is very easy. You simply create a new stream, set the desired level of capacity with shards, and then scale to match your data throughput rate and volume. You can get started in minutes by creating a data stream from the AWS console and start sending and consuming data. Your data is stored in shards that can scale up to 2 megabytes per second of read throughput for standard consumers. You can process that data with multiple applications and replay it as many times as you wish. You can retain your data for up to a full year. The default option is 24 hours, but you can retain that data for up to a year with the recently launched long-term retention option. You can also build real-time applications, perform continual processing on streaming data using the Kinesis Client Library or KCL, Apache Spark or Storm, AWS Lambda, Kinesis Data Analytics, or many other third-party applications. It is low cost and cost efficient for workloads at any scale. Common use cases include decoupling systems, event-driven architectures, multiple consumers for a message, microservices architectures, and change data capture. Let's take a look at what Amazon MSK does for you. As mentioned before, Apache Kafka clusters are challenging to set up, scale, and manage in production. Amazon MSK makes it easy for you to build and run production applications on Apache Kafka without needing Apache Kafka infrastructure management expertise. All this saves valuable engineering resources that are not cheap. MSK reduces the need for upfront investment in infrastructure and human resources and makes Apache Kafka more accessible to your organization. That means You spend less time managing infrastructure and more time building applications. With Amazon MSK, using the AWS console, the AWS CLI, or APIs, you can easily provision clusters, specify configurations that can be used across multiple clusters, use multi-AZ deployments for high availability, do one-click live upgrades as a service upgrades the cluster using rolling version upgrades, add additional nodes, and dynamically scale broker node storage while still producing and consuming data. It also allows you to easily enable monitoring and alarming on the cluster. Among other benefits, the service drives best practices through design, defaults, and automation. Next, let's talk about the AWS Glue Schema Registry, which was released in November of 2020 and was a highly requested feature. It makes it easy for developers to centrally discover, control, and evolve data schemas, which are essentially the structure and format of a data record. It helps improve data governance and quality for data streaming applications. Modern organizations in every industry use data streaming technologies like Amazon MSK and Amazon Kinesis to capture and distribute data generated by applications, websites, or machines. These technologies are highly available and they help decouple the data producing applications from the data processors, performing real-time routing, analytics, or machine learning. However, it's hard to coordinate data formats and structures across so many systems owned by so many different teams. Teams have a hard time using each other's data, and when formats change, downstream teams and applications have to adapt. They often build complex tools or custom code to ensure data continuity when schemas evolve. AWS Glue Schema Registry prevents downstream failures caused by schema changes and boosts productivity for developers by enforcing schemas where data is produced before the data gets sent downstream. Schema enforcement can be customized by the customer using one of 8 compatibility modes. Convenient integrations with Amazon MSK, Amazon Kinesis Data Streams, and Amazon Kinesis Data Analytics for Apache Flink are available for easy setup. Also, open source serializers provided by the Glue Schema Registry can serialize data into a compact binary and compressed format, making it easy for customers to save on their data transfer and storage costs. Also, the Glue Schema Registry is serverless and free to use. Now let's talk about Kinesis Data Firehose. So Amazon Kinesis Data Firehose is the easiest way to reliably load streaming data into data lakes, data stores, and analytic tools. You can capture, transform, and load streaming data into Amazon S3, Amazon Redshift, Amazon Elasticsearch Service, HTTP endpoints, and third-party provided destinations like Splunk, New Relic, MongoDB, and Datadog. It enables near real-time analytics with existing business intelligence tools and dashboards you're already using today. It is a fully managed serverless service that automatically scales to match the throughput of your data and requires no ongoing administration. It can also batch, compress, convert the data to columnar formats like Apache Parquet, do inline transformations, and encrypt the data before loading it, thereby minimizing the amount of storage used at the destination and increasing security. We now get to the stream processing part of it. Stream processing refers to the real-time processing and analysis of continuously streaming data and is tied to the outcome you would like to see from a streaming pipeline. There are multiple ways to process data from Amazon MSK, which has deep integrations with many AWS services, including AWS Lambda, Kinesis Data Analytics for Apache Flink, and AWS Glue Streaming ETL. Lambda is the simplest way to process data from Amazon MSK. You simply build a function using your language of choice, attach to an MSK topic, and processing is automatically triggered. You can control the batch size. And in Lambda, typically the processing is stateless. However, recently Lambda launched stateful functions for a very small subset of cases with Kinesis data streams for simple aggregations over a tumbling window. Amazon EMR allows you to utilize frameworks such as Apache Spark Streaming and Apache Flink, which gives you a low cost and flexible cluster customization on Amazon EMR. Amazon Kinesis Data Analytics is purpose-built for stream processing. It comes in two flavors. The one that was introduced first uses a proprietary SQL engine that supports the majority of the ANSI 2011 SQL standard with some extensions to support streaming applications. It can handle sub-second end-to-end processing latencies depending on the type of processing. It can consume from Kinesis data streams or Kinesis data firehose as sources and can send to Kinesis data streams or Kinesis data firehose or Lambda function as a destination. It allows processing via a rich set of functions that can be called from SQL statements, which include aggregation, analytic, statistical, and machine learning functions. The SQL statements can be chained together via intermediate in-memory tables called in-application streams. It supports common stream processing constructs like windowing with common windows like sliding windows, rolling windows, and stagger or session windows. The other engine that Amazon Kinesis Data Analytics supports is Apache Flink. Apache Flink is a framework and distributed processing engine for stateful computations over unbounded and bounded data streams. Flink has been designed to run in all common cluster environments, perform computations at in-memory speed and at any scale. Apache Flink uses a simple API, provides extremely low latency processing as well as high throughput. It can maintain and manage state, both system and user state. And finally, it provides exactly once processing semantics. Kinesis Data Analytics for Apache Flink provides serverless and fully managed Apache Flink. All you have to do is to create an application using the Apache Flink API and upload a jar file to Amazon S3. Then you create a KDE application referencing the jar file, and we will run the application for you. There are many customers using AWS streaming solutions, some of which are shown here. Let's talk about one of the customers. So Zillow is one of the most popular online real estate website and mobile apps in the United States. It provides updated home information to tens of millions of buyers and sellers every day. A primary feature of the Zillow website is the Z-Estimate, which is a home valuation tool that provides buyers and sellers with the estimated market value for a specific home. Zillow currently offers these Z-Estimates for more than 100 million homes in the US, with hundreds of attributes for each property. Zillow uses a wide variety of public record data, including tax assessments, sales transactions, images of homes, MLS listing data, and other information provided by homeowners. Because distributed big data technologies didn't exist more than 10 years ago, Zillow built an in-house machine learning framework that ran on premises. However, as the amount of data has grown and the complexity of machine learning models for accurate Z-estimates has increased, the company struggled to provide timely Z-estimates. The company specifically sought out a distributed platform which would enable the fast creation and execution of massively parallel machine learning jobs. So Zillow modernized the architecture of the machine learning algorithms by benefiting from the high scalability and continuous processing capabilities of AWS's streaming technologies. They use Amazon Kinesis data streams to ingest a variety of data. All this data is ingested and pushed into Apache Spark on Amazon EMR, which runs machine learning models and gives users near real-time Z-estimates. And then the same dataset is sent in parallel from Amazon Kinesis data streams to Amazon Kinesis data firehose, which batches the data in 15-minute intervals and delivers it to Zillow's centralized data lake on Amazon S3. From the data lake, a number of applications such as personalization, advertising optimization, and recommendations use the data without storage scalability concerns. Zillow can compute Z-estimates faster, therefore, and more frequently, because Amazon Kinesis data streams and Apache Spark on Amazon EMR enable near real-time data processing. Quoting their VP of Data Science and Engineering, quote, "We can compute Z-estimates in seconds, as opposed to hours, by using Amazon Kinesis data streams and Apache Spark on Amazon EMR. As a result, the Z-estimates are more up-to-date and accurate because they're built with the absolute latest data. That's a huge benefit for our users who depend on this information to influence their buying or selling decisions." End quote. Also, by using Amazon Kinesis data streams, Zillow does not have to be concerned with managing and scaling a fleet of servers for ingesting real-time streaming data. In addition, Zillow can easily scale its platform as it continues to grow. They have raw historical data in one place using Amazon S3. That gives them a central place to store almost infinite data cheaply. Based on their success with Zestimate, Zillow now uses Amazon Kinesis Data Streams and Apache Spark on Amazon EMR to power machine learning for all Zillow Group brands. Next is Netflix. That needs no introduction. Netflix uses AWS for nearly all of its computing and storage needs. Let's take a look at how they improve the availability and efficiency of their network to improve their customer experience using the scalability and high throughput capabilities of Kinesis Data Streams. Monitoring and optimizing its network is critical for Netflix to continue improving customer experience, increasing efficiency, and reducing costs. In particular, Netflix needed a solution for ingesting, augmenting, and analyzing the multiple terabytes of data its network generates daily in the form of Virtual Private Cloud or VPC flow logs. This would enable Netflix to identify performance improvement opportunities, such as identifying apps that are communicating across regions and co-locating them. The company would also be able to increase uptime by quickly detecting and mitigating application downtime. The solution Netflix ultimately deployed, known internally as Dredge, centralizes flow logs into using Amazon Kinesis Data Streams. The application reads the data from Amazon Kinesis Data Streams in real time and enriches IP addresses with application metadata to provide a full picture of the networking environment. Dredge joins the flow logs with application metadata as it streams and indexes it without using a database, which eliminates a lot of the complexity. The enriched data lands in an open source analytics application called Druid. Netflix uses the OLAP querying functionality of Druid to quickly slice data into regions, availability zones, and time windows to visualize it and gain insight into how the network is behaving and performing. Netflix's Amazon Kinesis Data Streams based solution has proven to be highly scalable, and it each day processes billions of traffic flows. Typically, about 1,000 Amazon Kinesis shards work in parallel to process the data stream. So Amazon Kinesis Data Streams processes multiple terabytes of log data each day, yet events show up in their analytics in seconds. Netflix can discover and respond to issues in real time, ensuring high availability and a great customer experience. Netflix is now able to identify new ways to optimize its applications, whether that means moving an application from one region to another or changing it to a more appropriate network protocol for a specific type of traffic. That brings us to the end of this session. There are a number of resources on the slide that can help you go from 0 to 60 on the AWS streaming services in no time. I encourage you to check these resources out. Now, you joined the AWS Summit to learn, and you can keep the learning going after the summit with resources from AWS training and certification. We offer many free and on-demand digital courses, as well as virtual instructor-led training. AWS experts will help you or your team learn to build and validate your data analytics skills. When you're ready, prepare for the AWS Certified Data Analytics Specialty Exam, which validates your skills and provides an industry-recognized credential. For more information, visit aws.training/analytics and be sure to check out our AWS Ramp-Up Guide to learn more. Hope this session was useful. Please don't forget to complete the session survey. We appreciate your feedback.